All right, my friends, a whole lot going on in this network. I barely got it up here, all up here on the screen. And in this network, we are going to see stub areas and total stub areas in action. Now, this goes back and forth between being in the CCNA and not being in the CCNA. They seem to flip it every version. But to be blunt, even if this doesn't show up on your exam somehow, you need to see it because stub areas and total stub areas are very common in OSPF deployments. And I don't want you getting your NA or getting a new job or something like that, and then all of a sudden you're not exactly sure what stub areas and total stub areas do. I've mentioned stub areas in passing a couple of times also, and I don't really like to do that when I would just mention, well, sometimes you got a router that doesn't need a full routing table. I want you to see one of these and exactly what's going on with both a stub and a total stub. Also, you'll then be able to compare these techniques to the use of the default information originate command, which we're going to look at in the next video. That I can practically guarantee you is going to be on your NA exam in one form or another. And I want you to know the differences and the similarities between what that command does and what these stub areas and total stub areas do. So before we dive in, let's take a real quick look at the diagram here because we got a lot going on. We do have our usual suspects here as far as the NBMA between routers 1, 2, and 3. That's our 123.0 network. We have a broadcast segment connecting routers 3 and 4, 172.12.34.0. And as for the loopbacks, they're using their number for each octet except loopback 33 over there, which is connected to router 3, and it is 33333/32. Also, did a little route redistribution here, which we have not done to this point. It's something else that goes back and forth. We're not getting into the technique of route redistribution right now, but the thing is with OSPF, when you redistribute routes into OSPF, those are called external routes. They came from an external source, whether it be a connected one that was redistributed or they were learned by another protocol and injected into OSPF. So that's why I have redistribute connected subnets up there for 6, 7, 8, and 9. So they're going to have a different code than the other routes that we have in this table. So as far as R4 is concerned, we got a lot going on. We got one route that's in area 34. We got that loopback 33. We have some routes that are in other areas. And then we got this redistribute connected subnets thing with some kind of external route. So a lot of different route types showing up on router 4. Let's go to router 4 and have a look. And this is router 4's OSPF routing table at this point. And you can see that already, even with a few additions and a few changes, it's getting pretty big. And you'll notice first off, let me bring the codes down a little bit here. Can't squeeze it all in. But first off, we do have one just plain old OSPF code, and that's the one for the 33 network there near the bottom. And it just has the letter O in it, indicating it's a local route. It's one that's in an area that router 4 is connected to, and it's in area 34. We know that. We've seen these inter-area routes before. Inter-area routes are indicated by the letters IA, and they are routes to destinations in other areas. And we see that 1, 2, and 3, which we know are in areas 1, 2, and 3 respectively, are marked IA, as is the 172.12.123.0 network down here at the bottom of the table. Now, as for these babies, 6, 7, 8, and 9, again, those were not put in with the network command. I used a command on router 1, redistribute connected subnets, did some route redistribution. And the reason I did that was to give us some external routes to work with. And this is the default code you're going to see next to any route that OSPF learns by default, route redistribution. It's going to have E2 next to it, next to the O. So router 4 has a destination to a local route, has destinations to intra-area routes, or inter-area routes, and then finally to external routes. So now, boy, wouldn't it be nice if we could bring this table down a little bit in size? Because the thing is, it's just going to get bigger and bigger and bigger. We could bring router 5 back into the mix and put 40 loopbacks on there, or we could just add 40 loopbacks to router 1. Man, you know, this table would be 3 screens long. And the thing is, not only does it make it a little cumbersome for the naked eye to parse, but it also makes it a little cumbersome for the routing engine to parse. Because that router is looking for the longest match. It's going to go through the entire table or parse it. And the thing is, what values does router 4 have in common for every single one of those routes? The next hop IP address. Let's look at these now. The administrative distance note for all of them is 110. That's always the OSPF default no matter what kind of route it is. But whether it's our IAs or our E2s or just plain O's, the next hop IP address is always 172.12.34.3. So the entire lookup process in the routing table really is a waste of time because they're always going to go to 34.3 packets leaving router 4 because frankly, that's the only place they can go. So this is ripe territory to configure an OSPF stub area. And that's what I was talking about earlier a couple of times when I mentioned, sometimes a router doesn't need a full routing table. This is one of those times. And when we configure a stub area, router 4 will have a default route, and some of the routes in that table are also going to be removed depending on whether you create a stub area or a total stub area. Before we get started with that, got to bring up adjacencies again, because this is another value that neighbors have to agree on in order to become adjacent in the first place and also to keep an adjacency. It doesn't get mentioned a lot in CCNA training, pardon me, but you need to know about it because, again, it goes back to the stub area thing. If you're not configuring stub areas, you're not thinking about this, but we are, so we have to. Every router in the area must agree on whether this is a stub area or not. That's it. It's not a total stub agreement. They just have to agree, is this a stub area of some type or is it not? And if there's a mismatch, which I think we're going to see in just a minute, adjacencies are going to start to drop. A couple of terms you should be familiar with creating a stub area. One is setting the stub flag, another is setting the stub bit. But when that is set on one router in the area and not others, the result is going to be a dropped adjacency. And again, I have a feeling we're going to see that here in just a moment when we configure first a stub area and then we will go to total stub. So the command, like I said, it's kind of like passive interface. It's a lot of theory and a lot of things to look out for, and then the command is actually pretty simple. We're going to use the area command again, just like we did with virtual links. And there's stub right there next to the bottom to specify a stub area. Makes sense. And a couple options we don't really care about right now, and we'll go ahead and hit enter. And boy, it didn't take that adjacency long to drop. And that's because right now they disagree on the stub bit setting. Router 3 is saying this is not a stub, if router 4 is saying it is. So let's go over to router 3, change its mind, and see what happens. It should come back up pretty quick. The options, we have no summary only on this one, so we'll go with that. Just area 34 stub. And I've seen this before. You see the message about it having gone down first, and then a few seconds after that it goes from loading to full, but everything's fine and our adjacency is back in place. So we can run show IP OSPF neighbor. And there's our neighbor adjacency. Nothing here about it being a stub area, anything like that. Let's have a look at the routing table. And it's a little smaller. What's missing? What's removed? Those external routes. With this one simple command, we've cut the routing table almost in half because the external routes to loopbacks 6, 7, 8, and 9 up on router 1 are now gone. That's what a stub area does. A stub area will result in you still having your regular OSPF entries and your inter-area entries, but it will remove external entries, and then it's going to put this default route that we see at the very top to 0000, and notice what the next hop IP address is. The only one it can possibly be. So just with that one simple command, we've already knocked the routing table in half. And that's a really good deal. And what we will do at the beginning of the next video is make this a total stub area, and we'll see how much further down we can shrink this table and still keep connectivity. See you there.